So important theory to write down in your book here is for when two complex numbers are equal. So numbers are equal in complex numbers if their real parts are equal and also if their imaginary parts are equal. So here they're talking about two different complex numbers. We often use a little subscript down here to talk about what z. So z1 might be 1 plus 3i, and z2 might be 1 plus 2i. So you can see here that even though you've got the two imaginary, or the two real, I should say, parts of the z's are equal to each other, they're both 1, their imaginary parts are not equal. So the thing to be very careful of here is that you have to compare both the imaginary parts and the real parts of those numbers. So the real part's the same, imaginary part's different, these two are not equal. Okay, so that might seem really obvious, but the nice thing about this is that if you have unknowns, like we're going to be dealing with here, a and b, in an equation, what you can do is you can actually say, if you know these are equal, these two numbers that you're comparing are equal, you can use these relationships that the real parts have to be equal and the imaginary parts have to be equal to solve the equation. So let's solve this equation. We've got 2a minus 3 plus 2bi, and you can see that that 2a minus 3 is in brackets. It's just to identify that this is the real part here. That's the real part of the complex number. We'll just call this side z1, and this is the imaginary part of z1. Okay, and we've got that has to be equal to the other side, 5 plus 6i, and on this side it's a bit easier to see the real part. We'll call this other side z2. And the imaginary part, remember that the imaginary part is only ever just the number, it's not the I as well. So we're told here, because this is an equal sign, this side here has to be equal to the other side. What that means is that the real parts should be equal and the imaginary part should be equal. So for the real parts, the real part of z1 to be equal to the real part of z2, we've got 2a minus 3, that's the real part, should equal 5. And with a bit of algebra you can see 2a equals add 3 to both sides. So a, divide both sides by 2, a equals 4. So we've got our solution for a. And then comparing the imaginary parts, the imaginary left-hand side and the imaginary part of the right-hand side. You could also write this as left-hand side and right-hand side if you'd like, inside there, as long as you've just stated somewhere what you're letting z1 equal. I've done it above the question, but you should formally write it down so that people can see. We've now got 2b equals, remember the i's, you don't need those, we just need the imaginary part. 2b equals 6. Okay, the imaginary parts are equal, and so dividing both sides by 2, we've got b equals 3. So we've actually solved this equation, and we can check too. You can see here that a should be an element of the reals, it is a real number, and b should also be an element of the reals as well, and both of our solutions are real numbers. So using that key idea that if two complex numbers are equal, their real parts and their imaginary parts should also be equal.